So why exactly neurosurgery? Well, in order to perform neurosurgery, there are some criteria that should be taken into consideration. Like, for example, anatomical mapping. So you gotta know where are you aiming to perform the surgery. Functional mapping. Entry region, you gotta find the proper position in order to perform the surgery. Trajectory. So you know, you have to know the depth that you're gonna go into regions to avoid. You don't want to have any complications or do something wrong. And the target point, the target that you want to reach at the end. So apparently all of this needs a lot of precision, so a high level of preciseness to diminish the margin of error. And this is why such neurosurgical operations are labeled any invasive or less invasive. And when we talk about that high level of preciseness and exactness, robotics come to mind, because for us this resembles that high level of discipline. And so by today's standards, when we look at the technological advancement that we have and the high precision requirements that neurosurgery needs, and the limitations of neurosurgery without robotics, robotic neurosurgery comes to be the solution for all of this, combining all these three possibilities, offering precise stereotaxis. Imaging systems can be integrated throughout neurosurgery, like MRI and CD, and it also provides better tracking and targeting. So this is what we're going to talk about. We're going to review some of the current neurosurgical robots, their advantages, disadvantages, and so on. So I'd like to start with Neuromate, which was developed in California in 1987, which is pretty interesting. So it's not pretty recent. Since the beginning of, or the peak of the advancement in robotics, that idea came to mind, like, to use robotics in such a very precise operation. It's a stereotactic system with 6 degrees of freedom, and it's pretty interesting because the frame-based Neuromate robot, its preciseness is comparable to that of standard localizing systems, and the application accuracy for Neuromate in electrode implantation was better than 1 millimeter, which makes it suitable for electrode implantations and deep brain stimulation procedures. Another robotic device was called Minerva, and that one had a disadvantage. So it was CT compatible, but as we can see in the image, it's pretty bulky, and it's not very friendly to the neurosurgeon to use such a device. So it was developed in 1991, but its production stopped in 1993 due to the large size of the device and its uncompatibility. Another device that integrates an imaging system is called NeuroArm. This one integrates MRI, and it was developed in 2001. And as we can see in the image, the neurosurgeon is controlling the robot through monitoring systems away from the device, and we can see in the image below how the arms are performing the neurosurgery. In 2008, it was used to remove a brain region successfully, and since then, it was used in around 1,000 neurosurgical operations. Another kind of robotic device used in neurosurgery is CyberKnife, and this one is non-invasive radiosurgery system. It's used in spinal stereotactic radiosurgery with added precision by repositioning the patient through another device which is developed by the same company that made that product, which is called the RoboCouch. So it repositions the patient automatically throughout the surgery, giving more precision. And in 2012, it performed a successful radiosurgery of an intracranial plastocytoma. One of the very famous robotic devices used in neurosurgery is the Da Vinci system, developed in 2000, in year 2000, and initially the device was used for like operations in urology, but currently it's very, very famous in the field of neurosurgery. What gives us this advantage is that it has 2 master manipulator arms and 4 slave arms, each with 7 degrees of freedom. And this gives the neurosurgeon more relaxation and compatibility with the device to work with. Another one is robot, which was developed in Japan, although the name is German. And it also has successful neurosurgical operations, as we can see. One example for uncompatible systems is Evolution 1, which had problems with its high cost and its bulkiness also, so it wasn't friendly for the neurosurgeons to work with. To end, I'm going to end with that. It's in 2015 in Croatia, some researchers, they're working on this new robotic device, which is called RONA, short for robotic neuro navigation. And this one has a dual arm system, each with 13 degrees of freedom, with a navigation and planning software, localization features, and operating tools, as you can see in the images, which sounds really great. So they're still working on it. It's pretty novel, so in 2015. So we come to the conclusion that by today's standards, robotics are integrated everywhere, and we need such a tool in order to perform successful neurosurgeries, because as we see, they improve the practice and yield very good results. Bibliography, and thank you for your attention.
Assuming you want to become a neurosurgeon, which one of these robotic systems you presented would you choose to perform a robotic neurosurgery?
I would choose the Da Vinci.
Right.
Because currently that's the one with the, let's say, it's very compatible with a surgeon. Like, you work very relaxed, you have like plenty of space to work with. You have 4 arms, each with like 7 degrees of freedom, which is pretty good. That new one with like 2 arms, 13 degrees of freedom, I don't know how would that work out. But till then, I would choose Da Vinci, I guess.
Okay, thank you.
As for the educational activities, in this channel we do for free. I've been making high school subjects tutorials since I was 16 years old, and I'm still making these tutorials. Also this year I started making tutorials about medical curriculum like anatomy, physiology, biochemistry, and so on.